The summary of toward causal deep learning for vulnerability detection. This paper was published by some researchers named Habibur Rahman, Irachika, Mao, Soikat Chakraborty, Boishakhi Roy, and supervised by the Professor Dr. Willy. I'm Russell Khondokar going to report on this paper. Actually, I made a summary on this research. In the abstract section, author mentioned deep learning vulnerability detection has promising result in recent year, but there is a challenge in this field. So that was basically model was not robust under the perturbation. As a result, they cannot generalize in OOD. OOD mean out of distribution data. Basically, model was failed in the unseen data. So to solve this problem, the first step was the uh, hypothesis. Author considered a hypothesis that was the because of feature like variable name, API name, probably model cannot perform in the out of distribution data. So these features also called spurious feature, and this relation with level called spurious correlation. In this paper, author basically introduced causality-based deep learning for the problem of vulnerability detection. This approach was also called causal val, which includes two phases. In the first phase was discovering spurious feature, and the second phase they removed this spurious feature. The result was model consistently improved accuracy, removed the spurious feature, and able to perform in the task like vulnerability detection for the unseen dataset. This work was the first work that used do calculus based causal learning to software engineering. So let's talk about what problem author addressed. So vulnerability in code helps attacker to break the security of a system. As a result, data and financial loss may happen, and it can be a dangerous situation by the attacker to a system. So in recent year, many researchers have researched on this field, and they was able to show promising performance, but the main challenge was the spurious correlation between input features and the target label. So spurious correlation is a relation where the model uses some features that are actually not the root cause of being a code vulnerable, but model wrongly identified that feature is the main cause of being a code vulnerable. So this feature prevent the model from being robust and being unable to apply to unseen projects. The aim was to disable model to use spurious feature and promote the model to use causal features for prediction. Previously, there was many research on this topic like Debegon and Rebel, where the author used GNN based architecture. Recently, there are some research where they applied transformer architecture, for example, CodeBird, where author used MLM objective. MLM means mask language modeling. They used this technique on both code and comment for pre-training. Graph code BERT leverages the semantic meaning of code information such as data flow to enhance their pre-training objectives. Unix Coder was another research where they leverage cross-model contents like AST, and comment to enrich code representation. So there is a research by Saito, and it is called Saito ETL. They investigate the perturbation on source code that cause a model to change its mind. And Mao ETL address robustness generalization in vision domain using causal learning. So if we talk about the what author did in this paper, so at first they consider a hypothesis that was the variable name can be a spurious feature, and based on this hypothesis, basically this hypothesis is came from domain knowledge, and based on this hypothesis they perturb their data set by using refactoring tool, and they ensures the semantic meaning of the code exists after the perturbation. The observation was model likely relied on this spurious feature, and after during the refactoring they make sure which variable name changed by which names, I mean, to ensure the semantic meaning of the code. So to solve this problem, training data augmentation can be used for like removing spurious feature, but it have problems like it takes time for the larger models. So instead of using data augmentation, the causal learning was the best way that proposed by the author to solve this type of question problems. So to give an overview of this work, in the first stage was the discovering spurious feature, and in the second stage they removed that those spurious feature that identified by the previous stage. So in stage 1 their hypothesis was about variable name is spurious feature, and they made perturbation and make sure keeping semantic preservation on code, and then they checked does model prediction changed or not, and they got model prediction changed, even though the semantic meaning was same. So and then they proved their hypothesis was the correct, and then they are in the second step they are planned to remove the spurious feature that identified by the previous stage, and they trained their model and make sure there is a bias on spurious feature, and during inference those bias are removed by using marginalization, and they make sure the spurious feature is disabled during inference. So this was the overall uh, overall approach by the author. The contribution was discovering and demonstrating variable names and API names are spurious feature in the current deep learning vulnerability detection models, formulating deep learning vulnerability detection using causality, and apply it causal deep learning to remove spurious feature in the models, and they demonstrates causal deep learning can improve model accuracy, robustness, and generalization. In this paper, author proposed the first step toward causal vulnerability detection and address several important challenges for vulnerability detection. There are some possible extension in this work. So discovering more spurious feature and exploring causal learning for other application in software engineering can be an impactful thing in software engineering. Applying, and I have few opinion about this research, and I believe there something can I do in these papers, like I can apply a state of the art LLM to figure out spurious feature. And also I believe applying interpretation analysis, attention analysis, and interaction matrix analysis can be a useful thing in these types of solving these types of problems. So thank you.